Hello and welcome back. Let's do some more, let's work with some more units. So here we've got a concrete path. It's going to be laid, it's going to be 12 feet wide, 840 feet long, and 6 inches deep, if I could spell. Concrete costs $75 per cubic yard. Determine the cost of the path. Okay, so first things first, I want to look at our cost of concrete. So this is going to be $75 per cubic yard. And per, remember, is divided by. This is going to be $75 divided by cubic yard. And cubic yard, remember cubed, is to the third power. Is going to be yards cubed. So if I need to find out how much the path is going to cost, I'm going to need to multiply. To get rid of the yards cubed on the bottom, I'm going to need to multiply by how many yards cubed the path is going to be. So this is the number that I need to figure out to get my answer. So this number is what I need. If I take $75 per 1 yard cubed, per 1 cubic yard, and I multiply that by the number of cubic yards of concrete I need, I'm going to know how much. I'm going to know exactly how many how many dollars the path will cost. So let's figure out how big the path is. Let's draw a picture, a very quick picture. Our path is going to be 12 feet wide, 840 feet long, and 6 inches deep. So not very deep. And if everything is in feet, I want everything to be in feet. So for instance, this 6 inches, 1 foot is 12 inches, so 6 inches should be 1/2 of a foot. So then we have ourselves a rectangular prism, and the volume of a rectangular prism is going to be the length times the width times the height. So this is fairly straightforward. So if I take 12 feet times 840 feet times 1/2 a foot, I get, so let's come over to decimals, and I'll take 12 times 840 times 1 divided by 2, and everything makes sense. What's that? Were these the numbers? 12, 840, and 1/2. And this is 5,040. So let's come back over here. So this is going to be 5,040. And we're taking feet times feet times feet. So that's going to be cubic feet. But right away, we notice I don't want cubic feet, I want cubic yards. So I need to know how many cubic feet are there in a cubic yard. Well, this is something that we did on the last homework assignment. We know that 3 feet is going to be 1 yard, and I need to cube everything. I need to raise everything to the third power. So if I raise both sides to the third power, 3 times 3 times 3 is 27. Feet cubed is going to be equal to 1 times 1 times 1, which is 1 yard cubed. So here's my conversion factor. 1 yard cubed is going to be 27 feet cubed. So let's convert 5,040 feet cubed into yards. So I need to cancel out my feet cubed, and I need to get yards cubed. and there's going to be 27 feet, 27 cubic feet for every cubic yard. And let's come back to decimals. So we'll have 5,040 divided by 27, and that will give us this number here. What I'm going to do is I'm going to keep this in decimals so that I'll get an exact answer. So this is going to be, so I'll just write this down for now. 186 points, and then it looks like a bunch of sixes after that. So 186.666 forever yards cubed. So this number is what should go. It's up off the page. Is what should go right here. So let's copy this where we can see this a little bit easier. So this is going to be 75 dollars per cubic yard times this many cubic yards yards will cancel out, and I'll just be left with dollars, and this will be the price of our path. So if I come back to decimals, this becomes fairly easy because I can take 75 and I can multiply it by the previous answer. So I can just click answer, and it copies it down. It doesn't even round. So this is really nice. So 75 times that, and this will give us 14,000 exactly. So let's come back here, and we see that this is going to be 14,000. The dollars didn't cancel with anything, so this is going to be dollars. So there's a few steps in here. We knew that we had to cancel yards, cubic yards, to get just our answer in dollars. So I needed to find the volume of our sidewalk or our path in cubic yards. So we just had to convert the volume into yards, and we're good to go. Let's work with some more units here. A cube has a side length of 3 inches and has a mass of 150 grams. The second cube of the same material, so the same material, is 5 inches on a side. And what is the mass of the second cube? So the first thing that I really want to stress here is that mass and volume are proportional. So mass and volume are proportional. So what does this mean? We need to find the mass of the cube and the volume of the cube, and that same proportion will hold for the second cube. So what this means is that if I take the mass of the first cube, so I'll call this mass 1, and the proportion of that to the volume, so I'll call it volume 1 for the volume of the first cube. This proportion, this ratio, is going to be equal to the mass of the second cube to the volume of the second cube. So again, mass and volume are proportional, meaning that their ratios are going to be the same, provided it's the same material. A cube made of like a sponge is going to have a different mass than a cube made of, say, lead. So as long as they're made of the same material, the mass and the volume should be proportional. They should have the same ratio. So we need to find the mass of the first cube. Well, that's just given to us. That's 150 grams. But the volume isn't. We're only told the side length of the cube. Luckily, we have a formula for that. So the mass of the first cube, remember a cube is just going to be this rectangular prism. So all we need to do is take the height times the width times the length. And for a cube, they're all the same. So the first one is going to be 3 inches times 3 inches times 3 inches. 3 times 3 times 3 is 27. Inches times inches times inches is cubic inches. Cool. I did this completely wrong. This isn't a mass. This is a volume. I just about wrote something down incorrect. The mass of the first cube was given to us. This is just 150 grams. Okay, mass 2, the mass of the second cube, well, this is what we don't know. This is what we're trying to figure out. What is the mass of the second cube? And then the volume of the second cube, well, again, it's 5 inches on a side. So this is something that we can simply write down. The volume of the second cube, well, again, height times width times length, they're all the same if it's a cube. And this is going to be 5 inches times 5 inches times 5 inches. And this is going to be 5 times 5 is 25, times 5 is 125 inches cubed. So mass and volume for the first one is going to be 150 grams per 27 inches cubed. And this is going to be equal to some unknown amount of grams. I might as well call it X. Divided by 125 inches cubed. One thing I want to point out is that it's very important, if we're taking ratios, that we take ratios of the same units. This is grams per inches cubed. So our answer is going to be grams per inches cubed. Everything matches. So our mass up here is going to be in grams because our inches cubed on the bottom match. So, how do I solve for x here? Well, I'm taking x and I'm dividing it by 125 inches cubed. So in order to undo division, I have to multiply. So if I multiply both sides by 125 inches cubed, not inches, inches cubed times 125 inches cubed. This is going to be equal to x here. And again, inches cubed cancels out because I'm multiplying by inches and I'm dividing by inches. The only thing that's left is grams. And the only thing left to do is to multiply this out. So let's come back over to Desmos. And let's take 150 divided by 27. So this is our first ratio. We're going to take this times 125, and this is going to be equal to 694.4, it looks like forever. I'm going to round this to the nearest whole number, so the whole number would stop at the first 4. So this is going to be 694 grams after I've rounded it to the nearest whole number. So what you'll notice, and this is important, a side length of 3 going up to a side length of 5, that almost doubled the side length. 6 would be double 3, so it's not quite doubled. But look at the mass. The mass went from 150 to nearly 700. That's more than 4 times. What ends up happening is mass increases drastically if the length, if the side length of a cube is increased. And I will go through one final example in one last video for this section.